Hi everybody, today we're talking about measures of center, mean, median, and mode, and we will be using Rguroo as our technology to assist us in finding these measures of center. Now I mentioned 3 measures of center, mean, median, and mode, but on this first screen you'll see that there are 4 measures of center, so I've added an extra one that I think sometimes gets overlooked, but it is a good one to make sure that we know. And they all start with the letter M. The first one is mean, the second is median, the third is mode, and the fourth that may not be as familiar is mid-range. So these are the 4 that we're talking about in this video. And this first slide is just a really good summary slide. So this is a good one to come back to that will go through each of the 4 measures of center, explaining what they are and how to find them, as well as notations that represent each. So the first one we're going to talk about is mean. And so another word for mean is average. So a lot of times when people say find the average, what they're thinking about is finding what is called the mean. And this is where you add up all the numbers and divide by the number of numbers in the data set. So when we add numbers, a word for that is sum. So the word sum means add. So it says we're going to add all the numbers together in the data set, and we're going to divide that by the number of numbers that are in the data set. So if there are 10 numbers, you'll divide by 10. So what you'll notice is below this, there are 2 means. There's the sample mean and there's a population mean. So a sample mean is the mean of a sample. And a population mean is the mean of the population. And then for each one, you actually find them the same way. You add up all the numbers in the data set, whether it's a sample or whether it's a population, and you still divide by the total number of numbers. That doesn't change. What is slightly different, however, is the notation. So the first one we are going to look at is the sample mean. So here is the formula for sample mean right here. And so some of it may look a little weird because you may not understand some of the notations. So the first notation that I want to talk about is this X with a line over top. Okay, so this X with a line over top, it's pronounced this way. This is the way you say it, X bar. And it means sample mean. All right, so that's the first notation that may not be familiar. The second notation that you may not be familiar with is this symbol right here. This symbol here is an uppercase sigma. It's a Greek letter, and I specify that it is uppercase because we also have a lowercase sigma that we will learn later, and it looks a little different and it represents something different. So an uppercase sigma represents the word sum. So when you see it, it means add. So then the next thing in the formula is this X. So X, or later on you might see it this way, XI, it represents individual numbers in the data set. So if you had the numbers like 1, 2, 3, 4, then the X would represent each of those numbers 1, 2, 3, and 4 individually. And so what it's saying is add those numbers together, the 1, 2, 3, and the 4. And then you'll notice there's a lowercase n at the bottom. All right, that stands for the, I'll just write it this way, sample size. So it's the number of data values in your sample. So it's your sample size. So those are new notations. I did want to make sure that everybody knows that a fraction bar means divide if you didn't know that already. That means divide. So what this formula, the whole thing is telling you to find the sample mean, it means add up each number in the sample, add all the numbers in the sample together, and then divide by the number of numbers. Now, we move down to population mean, and you'll notice that the formula, it actually looks fairly similar to the formula above it for sample mean. So the population mean formula is very similar. It has some similar notations, but it also has some very different notations. So the first one that's different is the one that looks like this. I personally think it looks like the cross between an M and a U. Ironically, if you were to cross the M and U together and say it, it might come out something like saying mu, which is how you actually pronounce this symbol. So this symbol is the Greek letter mu, and it stands for the population mean. The next thing in the formula is sigma, which still means sum. X is still the individual numbers in the data set, but we do have a capital N. So capital N rather than lowercase n is the sample size, so uppercase N is the population size. Okay? So we would add up all the numbers, whether it's X bar for sample mean or mu for population mean, you add up all the numbers and then divide by the total number of numbers in the data set. So that is mean. Moving on to median. The median is another measure of center, but it is the middle of the ordered data set. So keyword here is it has to be ordered. All right. And then there is a little formula here when you can find the median position. It says n plus 1 over 2. I'm going to show you another way to find it. But basically, if you wanted to find out the median, you could use that formula. Let's say if there were 5 numbers. So you would say 5 plus 1 is 6, and 6 over 2 is 6 divided by 2, which is 3. So that means that the median would be in the third position. So you'd count the third number. But I'm going to show you another way to go about it rather than use that little formula. There is no special notation for median. You just write out the word median. Mode is the number that occurs the most. And the way I remember that is, I think, mode, most, mo. So the M-O, mode, most. So mode is the number that occurs most in the data set. And then finally, we have mid-range. And mid-range is a number that is midway between the least value and the greatest value. So when we say least value, we mean the smallest. So the smallest number in the data set and the greatest number in the data set. And we add those two together, and then we divide whatever we get by 2, and that will give us the mid-range. So there's that formula for mid-range. All right, so this is a great slide to go back to. That is a really great summary of much of what you're learning throughout this actual presentation. Keep watching though, because I go into more detail and I show you how to use Rguroo to find these as well. So let's look at the first example. It says, during a semester, a student took 5 exams. The population of exam scores is 78, 83, 92, 68, and 85. Find the mean. So notice they use the word population here. They say it's a population of exam scores. They add that word in here. So they're giving us a hint that this is a population of scores, which means we need to find the population mean when they tell us to find mean. It will be the population mean. But they might not always use the word population here. They might just say during a semester, a student took 5 exams. The exam scores were 78, 83, 92, 68, and 85. And it would be up to you to figure out that that is a population. Now, the reason this is a population is because this is all of the exam scores, which means it is a population rather than a sample. If it was only a portion of the exam scores, then that would be a sample. But because it's all the exam scores, we say it is a population. Therefore, we find the population mean. So just recall the formula. First off, the notation is mu is equal to the sum of all the x's divided by n. And that's what we do down here. Now I told you they sometimes add a little I. So the sum of all the x's, so they add 78, 83, 92, 68, 85, and then they divide by the number of numbers, so that's 5. So when they add these together on the top, we get 406. We divide by 5, and we get 81.2. So 81.2 is the average, the mean of the test scores. It's the center when you calculate it that way. So basically, these are all measures of center. So they're all calculating the center in a different way. And so if we calculate it this way, this measure of center is the mean. So 81.2. Now, you may be used to other math problems that tell you to round to 2 decimal places or round to the 10th position. For mean, they usually don't tell you what to round to, but there is a rule for you to know what to round to. And so that's on this next slide here. So it is good practice to round the mean to one more decimal place than the data that appear in the original data set. So if we were to have to round this previous problem, each of these data points are whole numbers. So if I were to go 1 decimal place past what this is, that would be, there are no numbers after the decimal, that would be 1 number after the decimal. So I would round to the first decimal place, which actually that's what happened here, except I don't think we had a round. I think it came out to be 81.2 quite nicely. So rounding actually wasn't required. But if we had to round, then we would have rounded this one to 1 decimal place. If you had, let's say you had separate data, let's say we had like 78.5, 83.2, 92.1, 68.9, 85.4. I'm just making up numbers at this point. Okay, so if you're wondering where I'm getting these numbers, I'm just saying hypothetically, if these were the numbers instead, and we were to find the mean, you would still add them together, you would still divide by 5, but this time you would round your answer for the mean to 2 decimal places, which is the 100th position. And the reason is because each of the numbers in your data set go out 1 decimal place, and so again, the rule is to go out 1 more than what's in the data set. So if they're all going out 1, you round to 2. If they're all going out 2, you round to 3, so on and so forth. So that's the rules for rounding for mean specifically. So this is when we're rounding the mean. This is the rule for that. Okay, so we talked about mean. Now we're going to talk about median. So median is kind of like the halfway point. When you put the numbers in order from smallest to largest, it's the number in the middle. So the big thing here is to remember to put your numbers in order first. So the way it works is when you find the number in the middle, that number is greater than the lower half but less than the top half. It literally splits it in half. And the thing to remember about median is if there are an odd number of numbers, there's a number in the middle. If there's an even number of numbers, there's no number in the middle. There's actually 2 numbers in the middle. So if there's 2 numbers in the middle, you actually find the average of the 2 in the middle, and that would be the median. So for the rules for the median, you have step 1. This one's super important. If you don't do this, you're going to get it wrong. Make sure you put the data in order from least to greatest, the smallest to largest, before you try to calculate the median. And then if there's an odd number of numbers, you do it one way. And if there is an even number of numbers, you do it a different way. So this is the way it works. What you do is, if there's an odd number of numbers in your data set, the median is the middle number, the one in the center. But if there's an even number of numbers, you find the average or the mean of the two numbers in the middle. Because if there's an even number of numbers, you don't have one number in the middle, you have two numbers in the middle. And so you would just add those two together like you're finding the average and divide by 2. So let's do an example. So the same numbers we had, same test. During a semester, a student took 5 exams. The exam scores are 75, 83, 91, 63, and 84. Find the median. So we're finding the median. All right, so you'll see the first thing that I'm doing is I'm putting the numbers in order. And so you can see that at the bottom of the screen. The numbers in order are 63 is the smallest, followed by 75, 83, 84, 91. And so this is what I do. Rather than to use that little formula we had on the front, this is what I do. I mark off each end, and then I mark off the next two until I get to the center. So the center would be 83. That's the easiest way I find to do it if you're doing this by hand. I did want to show you that this little formula, kind of how that works. The n plus 1 over 2, that is right here. I want to show you kind of how that applies if we were to do the same problem, right? So if I were to say n plus 1 over 2 to find the location of the median. So n is the number of numbers. So there's 1, 2, 3, 4, 5 numbers. So I would say 5 plus 1 over 2 would be 6 over 2, which is 3. So it would be the third number. So check this out. 1, 2, 3. So that's the other way that you can do it by using that formula, although I usually just start crossing off the ends until I get to the middle. Let's do one where there's an even number of numbers. So here's the numbers: 20, 15, 12, 27, 13, 19, 13, 21, and we put them in order. Okay, so let me just show you real quick. Let's cross them off, cross, cross, then cross off the next two, cross off the next two, and then if I were to cross off these two, then I run out of numbers. But I do have 2 in the middle. So that doesn't mean that you have 2 medians. What you have to do is to find the average. So you add 15 plus 19, and you're going to divide by those by 2 because they're 2 numbers. So that would be what, 34, I believe, divided by 2, and we get 17. You can see I've got it worked out there as well. All right, so let's just use that formula real quick and see how that works. If I had n plus 1 over 2. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. And then it would be 4.5. So I put it in order. Here's 1, 2, 3, 4.5. This is 5, 6, 7, 8. So even this way, you still have to find the average of the two because it's in the middle of 15 and 19. So you would add them together and divide by 2. Okay, so that is the median if you're finding it by hand. So that is followed by the mode, which we said is the number that occurs the most. The mode is the number that occurs the most. So here's some special things to note about mode. One is that you can have more than one mode. So if you have a list of data and a number, sorry, I'm moving things around. So if I have a list of data and 2 numbers occur twice and every other number occur once, then that means I can have 2 modes. There can also be no mode. So if every number occurs only once, then there's no mode. A data set with two modes is called bimodal. So bi, like bicycle, has two wheels. Bimodal has two modes. And then a mode, even though it's a measure of center, this is the interesting one. Even though it's a measure of center, it may not be in the center. So it's interesting that they call it a measure of center. I mean, it can be in the center, and many times it is in the center, but it's not always in the center. And so that's something important to remember. So here's an example. The number of books checked out from the library from 25 students are as follows. We've got all these numbers, which I am not going to read. You can see what they are. And basically, you can just see how many times each number occurs. So I'm going to use the help of some highlighting. Okay, so there are 3 zeros. And then there's 1 1. There is 1 2. But there are 2 3s. How many 4s are there? There are 2 4s. There are 2 5s. There are, oh, look at this, 4 7s. So 2 4s, 2 5s, 4 7s. There are 3 8s. There's 1 9. Oops. Trying to do different colors here if you can see those. 1 9. There are 2 10s. There are 2 11s, and then there are 2 12s. So you can see the one that occurs most is 7 because there were 4 of them. There are 4 7s. So the mode is 7. All right, so that pretty much takes care of mean, median, mode. Just as a side, just to remind us how we find mid-range. If I were to tell you to find the mid-range of this, you would do the lowest number plus the highest number. So x1 stands for the first number. Xn stands for the number in the nth position, and n is the sample size. So if there's 10 numbers, it's the number in the 10th position. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So Xn stands for the 25th number. And then when they're in order. And then you divide that by 2. So the smallest number is 0. The biggest number is 12. Divided by 2, you get 12 over 2. The mid-range is 6. So that's mid-range, not mode. Okay, so I wanted to go, I mean, each of these, they're pretty easy to do by hand if you have a small number of numbers, but when you have a large data set, that's when it gets a little bit more complicated, so it's helpful to have technology to help us out. So do you have the steps for using Rguroo? The first thing that you have to do before you can do anything is enter the data into Rguroo. If the data is already in Rguroo, no big deal, but if it's not, you need to put it in there. So this is the steps to putting data in Rguroo. Okay, the first thing you're going to do is you're going to go to that data tab and you're going to click data, the data import drop down, and you're going to choose create a new data set. So no matter what tab you have, there's always that little drop down that you have to click on and choose what you want to do. So you want to choose create new data set. That's the first thing that you want to do. All right, so then once you do that, the next step is to click on the horizontal row icon to add the number of rows you need. And you can, if you have multiple columns, you can use the column icon to add multiple columns. So those look like this. This is the row icon. It'll be at the top of your screen when you have the create new data set pop up. And this is for adding columns. So for every row you want to add, you click this. For every column you want to add, you click this. So basically, if there were 10 numbers, you'd want to click this until there were 10 rows available. And then there's a variable at the top of the row. You want to name it. That's helpful. And then you would enter your data. Now, instead of using the enter button, you use the down arrow to get from one cell to the other. And then when you're finished, on the top right, you'll see the Save As button. You want to give your data set a name and you want to save it. And so once you save it, it will show up under the Data tab, which is nice. So again, you go to the Data tab. In the drop-down, click Create New Data Set. Add the number of rows you need and label your variable, enter your data, and then save it. And that's it. It's actually fairly quick. All right, now if you start adding rows or columns and you realize you've added too many, you can delete by clicking these icons. These are also at the top. So if you click this one deletes a row, and this one deletes a column. All right, so that's very helpful. So those are the steps in Rguroo that we would use to create a data set. Okay, I want to go through and show you how to do what I just gave you the steps for. So I'm going to enter those 5 test scores as a data set in Rguroo. So I'm going to do that so that later I can show you how to find the mean, the median, and the mode. So you would click the Data tab on the left, and then you are going to choose Data Import drop down, and then you're going to go down until it says Create New Data Set. There's also Create New Table. That's something we'll use later, but for now we'll just Create New Data Set. And so this frame pops up. It says New Data Frame at the top, and so you can see here it says Add a single row. Here it says Add a single column. I have 5 numbers, so I need 5 rows. So there's already 1 row there. So I'm going to add another one, another one, another one, another one. So now there's 5. Let's pretend I added 6 and I didn't mean to. So if that happens, I can just click on the delete row and then it will delete it. Oops. Click on it first and then delete it. Now I'm back to 5. Now it helps to name your variable. So I'm naming my variable test scores, and then I'm going to put my test scores in. So the first test score was a 75, and I use the down arrow to get to the next cell, then 83, down arrow, and then 91, down arrow, 63, down arrow, and 84. Those were the 5 test scores, so you can enter those as well. And then I'm just going to put population of test scores. You can name it whatever you want, but name it something that you're going to remember so you can find it. See, I have a lot of data sets over here, so I need to know what I name my data so I can find it again. So you hit save, and unfortunately mine is not saving because my session has expired. So I'm going to pause this myself real quick and then re-sign in and then do this again off camera. Okay, I've just redid everything that I had done before. Now that I've logged back in, I'm going to hit Save As. And it says Data Set, Population of Test Scores, Saved Successfully. I'm going to hit click OK. Then I'm going to scroll down, and the bottom of my data set, you'll see Population of Test Scores is right here. If I click on it, it'll pop up again. So I'm going to close these out because I don't really need them. I'm just going to close out the editor. And I'm going to go back to the slide screen. Okay, so moving on, this was entering the data into Rguroo. So now that we have it in Rguroo, we can use Rguroo to find the mean, median, and the mode. And so it's actually pretty quick and easy to do this now that our data is in Rguroo. So we're going to start by clicking the Analytics tab. That's the first step. So the Analytics tab is the third one down. So we've got Data, we've got Plots, Analytics, and you're going to click on the Analysis drop-down menu, and you're going to scroll down and click on Numerical Summaries. So to find the mean, median, and mode, and actually a slew of other statistics, you click on Analytics, click on Analysis drop-down, and then click on Numerical Summaries. And once you do that, a box will pop up, and you're going to, the box looks like this. Okay, so you are going to choose your data set. This is important. It's not going to do anything for you unless you choose your data set. So you click on, you click the drop down here and you choose the data set. So here I've chosen cereal, but for what we're doing, we'll choose where we did that population of test scores, we would choose that. And then you can name your data summary if you want to. That's up to you. Otherwise, it's just called summary_1. And then if you have multiple variables, you will move the variable over into the selected column. So you can usually click and drag it, or you can click on it and then click the right arrow and it will move it over here. What's great about this is, let's say you wanted, like say for the cereal, you wanted to find the mean median mode for calories, total fat, and for, let's say, sodium separately. But if you moved all three over into the selective column, this will find all three for you at once and put it into a table. It's quite nice. So again, you're going to choose your data sets. You can name your data set, but again, your summary of your data set, but again, that's optional. You have to choose the variable or the variables that you want to find the mean and the median and the mode for, and move it from the center column to this far right column titled Selected. So once you do that, you're going to click on underneath right here. You can't see it, but underneath here, there's a button that says Univariate. You're going to click it, Univariate, and then a box that looks similar to this will pop up. You can see you have a whole list of choices of what it is. You can have it find for you. Right now, we just want mean, median, and mode. So you click those three, and as soon as you're ready, you click on the eyeball icon and it will calculate all three of those, the mean, the median, and the mode for you. Okay, seeing this in action, I'm going to minimize my data tab and I'm going to open up and expand my analytics tab on the left, and I'm going to choose the analysis drop down and go down to the bottom and choose numerical summaries and click on it. And then a box will pop up, and as I said, you have to select your data set, and I have a lot of data sets, so I've got to scroll down a ways. And my data set is called population of test scores. So click on that. Now there's only one variable in this list, so that's the only one that I need to move over, so I can click and drag it over like I did there. The other way to do it is click on it and click on the right arrow. And then we click univariate. So here's univariate right here. And then click mean, median, mode, or anything else that you're interested in finding. And then click preview. And here you have your summary. It says test score. Mean is 79.2. The median is 83. And the mode is not applicable. And I believe earlier we got something different, but I just went back and looked. The data set that I put in this time, one of the test scores was slightly different, 75, which changes the mean a bit. So this is accurate. And then what's nice about this is you can save, like I can say this is test summary data and hit save as, the save as button. And then once you do that, if you look under, this would be under the analytics tab, you can see here's the test summary data. So you can open that as long as you have it there underneath your analytics. You can open it and you can actually click the basics box to edit it however you need to edit it. So that's quite nice. Okay, so we've gone through the major calculations both by hand and with Rguroo. So now we want to talk about a couple more things. The first one is resistant statistics. So a statistic is considered resistant if it is not affected by extreme values. Now, an extreme value would be a value that's much higher than the rest of the data or much lower than the rest of the data. And the vocabulary word for extreme values is outlier, so you're going to hear that a lot. The median isn't resistant to outliers, but the mean, I'm sorry, I think I said that wrong. The mean is resistant to outliers. That means outliers won't affect the median, but they will affect the mean. So the mean is not resistant because it is affected by outliers. So here's an example. There are 5 adults living in a retirement community taking a pottery class. Their ages are 63, 65, 72, 81, and 60. Find the mean and the median age of people taking the class. So the mean age is 68.2 and the median age is 65. They're actually pretty close, right? But the instructor's daughter is given special permission to take the class. She's 10. Find the new mean and the median age of the class participants. So if I add this 10 to this data set up here, the mean is now 58.5. The median is 64. So notice the median was pretty close, right? It didn't change much, but look how much the mean changed. It went down from 68.2 to 58.5. So 10 is definitely an extreme value. It's much lower than the rest of the data, and you can see it has an effect on mean, but not so much the median. And so why is that important? Well, people can present statistics to you, like maybe they present the average, but it can be misleading because of, extreme values that could be in the data set that are not typical to the rest of the data. So that's where skewness comes in. We have different shapes. So what I want you to imagine here is if you had a histogram that we learned before is kind of underneath here. This is basically showing you the shape of the tops of the bars. So if the very center bar is the highest, and then it goes a little bit farther down on each side, it makes sort of a curve like this. So if your histogram that represents the data looks like this, or at least the shape of it, it is considered approximately symmetrical. And when it's approximately symmetrical, usually that means that the mean and the median are either equal or they're approximately equal. Okay? But then we have data sets that aren't symmetrical. So one thing it could be is it could be skewed to the right. Now, skewed to the right is when the higher bars are on the left and the smaller bars are on the right. So the direction it's skewed is where the smaller bars are. So the smaller bars are on the right hand side. So this is skewed right. And so one of the characteristics of when it's skewed right is that these extreme values on this right hand side, there's not many of them, but they're much larger than the rest of the data. And remember, outliers affect the mean, so it's actually pulling the mean further in the direction to the right. So the mean will be greater than the median when it is skewed right. And then skewed left is when the smaller bars are on the left-hand side. And so that would be where any outliers would fall. And those are pulling the mean down because they're lower. So it's affecting the mean and making the mean smaller. So in this case, the mean is less than the median. So when it's skewed right, the mean is more than the median, and when it's skewed left, the mean is less than the median. And those are definitely important characteristics to remember about the shapes of your the histograms for your data sets. So skewed or symmetric is that is the following data set approximately symmetric or skewed, and it has the gold medal wins by country. I would say, if you were trying to draw the shape here, it does look like, it's not perfect, but it does look like the taller bars are on the left and the smaller bars are over here on the right. The smaller bars are on the right. So if that's the case, then it is skewed right. Let's say you weren't able to tell that. The other thing you can do is you can calculate the mean and the median. And so the mean is 4.25, which is greater than the median, which is only 3.5. So remember, if the mean is greater than the median, the median in this case 3.5 is less than 4.25. So if the mean is greater, then that kind of goes with our what we think here, that it's skewed right. And I believe that is it. That's all we have for this lesson here. If you have questions, please let me know.